we will be going over our UL 924 emergency lighting relays along with their applications. Well, if I can make this work. Yep, there we go. All right, before we get into our emergency lighting relays, I will be briefly going over our company's history and product offering. If you have any questions during this presentation, please type it in the chat and our support team will get back with you shortly. Functional Devices has been designing and manufacturing USA-made electronic devices for the building automation industry for 51 years, teaming up with customers like Johnson Controls, Siemens, and Honeywell to round out a few. In 2008, we decided to expand our product line into the lighting controls world, focusing on UL 924 emergency shunt relays and expanding from there. Here is our company profile. We manufacture over 700 devices for building controls, HVAC, lighting, fire and security, and the wireless markets. The photo below is our world headquarters in Sharpsville, Indiana. The quality we offer to our customers are highlighted here. Reliability, designed with quality in mind, and we test every unit before shipping. No batch testing like you see from our competitors. Time-saving and cost-effective devices, ease of installation, made in the USA by Functional Devices employees, 5-year warranty, functionality on all systems, in-house sales and engineering support, custom products for customers' needs, same-day shipping for most items, and easy-to-navigate website with full product documentations. Functional Devices product overview, we have relays ranging from 10 to 30 amps from a variety of coil voltages, current sensors sensing from 1/8 of an amp to 150 amps, power supplies and transformers from 20 VA to 500 VA, power meters, network compatible devices like BACnet and LAN, wireless devices like in-ocean and Wi-Fi, metal enclosures, UPS devices, and lighting control devices. This is our lighting controls line from a glance. General purpose relays with voltages with 120 and 277, lighting panel latching relays, universal power pack and sensors, closet light controllers, step-down auto transformers from 277 to 120, and ocean wireless relays, 0 to 10 dimming relay, and newly released phased angle dimmer that has both reverse and forward phasing capabilities. And last but not least is our UL 924 emergency shunt relays. Here is our lighting team. Dave Cyphers is on the left, which is our product and OEM manager. And on the right, we have Amy Reed, which is our inside sales, and myself in the middle. In this section, I will be going over our emergency lighting and its code requirements. Emergency lighting is defined as light or lights that either stay on or can be controlled automatically to turn on during an emergency event, thus providing sufficient illumination while allowing occupants of the building to evacuate safely during a utility power loss. Emergency lighting is the most important section when it comes to a lighting control layout. Emergency lighting is a standard in new commercial, industrial, high occupancy residential buildings, manufacturing facilities, college dormitories, apartments, and hotels. The National Electrical Code, Article 700-14, requires all commercial and industrial buildings to have UL 924 emergency lighting devices in them. In 2017, the NEC code allowed UL 924 listed relays to be used, available in switching only and switching and dimming models. These relays are typically installed separately outside lighting relay panels, circuits, or at the fixture level. Now I'm going to pass the mic to Dave Cyphers to go over our USA-made, cost-efficient UL 924 emergency shunt relays and their applications.
Thank you, Matt, and good afternoon to everyone out there. Glad you could join us. In addition to the NEC code information that Matt shared, there are basically 3 types of emergency lighting controls. There is a bypass shunt, there's automatic load control relays, also known as ALCR, and the last is automatic transfer switch, also known as ATS. Today, we're going to be looking at UL 924 bypass shunt and automatic load control relays. First, our products are designed for applications that require emergency load to be switched during a normal power. Basically, what we're doing is creating a path for emergency power to eliminate the emergency fixture. Here we're showing a few models here. This is a bypass shunt relay here in the middle at the top. To our left is an automatic load control, more of a circuit level. And to the right here is more of a fixture level automatic load control. And then we also have what we call a remote test switch that will actually work with these two down here at the bottom, the ACLRs. Our products work with either a generator or an inverter application, where an upstream transfer device is transferring the normal power to emergency power during a normal power outage. Input voltages on our coils range from 24 volt AC DC, 120 through 277 volt AC, depending on which model you're looking for to specify in your project. Some models include contact ratings from 5 amp to 20 amp max. Some include 16 amp electronic ballast ratings for those LED applications. Many of the ALCRs have the ability to override 0 through 10 volt dimming applications. Our most recent model we'll show you here in a bit actually will give you the 0 through 10 volt dimming, and it'll give you the offer to dolly dimmable override capabilities, something new to us. And lastly, some of our models offer both fire alarm system input and remote test capabilities. First, let's look at our bypass shunt relays. This is just a typical application, but what we've got here is an automatic transfer switch upstream for generator and inverter purposes. We've got our utility power down here below. We've got our ESR setting out here in the middle to the right. And basically what we're doing is, with this type of product, is bypass or shunting around a wall switch, a lighting panel, or a lighting controller. And basically what we're doing is generating or moving the power to the normal emergency lighting out there. From there, this is our actual models. We've got a couple models of this. We've got an ESR 2401B and an ESR 2402B. Our nomenclature is, if you know anything about the rib side of the family, you'll know our nomenclature stands for something, and that 24 stands for 24 volt AC DC. Our 01 actually stands for 120 volt AC, and the B is the type of relay we've got. If you look at our second model there, it's an ESR 2402B. It handles the 24 volt AC DC. It also handles 208 through 277. Again, this is more of a circuit bypass shunt relay. It is a very hefty relay, 20 amp magnetic ballast. We do have a nice feature here with a 16 amp electronic ballast. It is a single pole double throw relay. In this application over here to the right, we're using the normally closed side. And what's happening there is you're using the normally closed contacts to actually create that path for that emergency light to come on. If you look over here at the drawing over here to the side, left, the actual photo, you'll see the normally open side here towards the bottom. And basically, this can also be used for a 0 through 10 volt dimming override relay. We do offer that. It sometimes is used, sometimes it's not. Primarily, this is a shunt relay just to go around those wall switches and so forth. Here we have what we call our normal emergency zone controller as a bypass shunt. In this application, basically what you're seeing is where we've got two zone controllers. And what we're doing there is showing you in the bottom section there a normal zone controller. And what's happening there is you got normal power running that controller and working the normal light down there at the bottom. At the top side, what you've got is an automatic transfer switch, which switches over that emergency power when needed, going through the emergency panel. And then what we're doing at the emergency zone controller is we're bypassing and shunting around so the switched hot and dimmed hot can actually be activated at the emergency light, leaving it full brightness when done. You notice the nomenclature over here, our ESR is 01P, coil voltage on that's 120. The ESR 02P, our coil voltage is 2A through 277. So we've got the standard voltages there used in the lighting world for sure. 20 amp contact ratings on these. The important piece is this is a double pull, double throw. So there's two sets of normally open, normally closed contacts there. Here you can actually see a normal emergency fixture controller bypass shunt. Little different application. This is kind of key towards more of the distributed controls. So you're looking at the fixture controls and sensors at that point in time. Again, this is a double pull, double throw. What you're going to see is how you end up using one set of contacts. So if you go to the bottom of there, you'll actually see the normal emergency power coming in. If this coil was activated, this would be closed here at this point. So what we're doing is feeding normal power around into the controller. When normal power drops, this coil deactivates. Then what happens is this opens up, and then what we're doing here is feeding the emergency power across this set of contacts, feeding out to the driver to bring it to full brightness. Again, that's an application that everybody doesn't use, but it is one that is out there that we do want to make sure everybody knows and is aware of. Next, we'd like to talk about automatic load control relays. The NEC code 700.25 says if an emergency lighting load is automatically energized upon a loss of normal supply, a listed automatic load control relay, that's ALCR, shall be permitted to energize the load. Mainly, one focus here is they do not want this to be used as a transfer device or a piece of a transfer equipment. And really what ends up happening is you have, with this, you have the utilization of lights on override with a fire alarm or emergency system. The way it kind of is here, if you look at the left-hand side here, you'll notice this is an ESRN. You'll notice you got an LED here, green LED, that's for normal power. You've got a red LED over on the right-hand side of it. That's for emergency power, and you've got your yellow status, tell you what the load's actually doing. The other feature of this is you got a localized test button. And primarily what that's for is when they do actually install this product in the plenum area, there are no bulbs in those fixtures. So they have to make sure they have it wired correctly. So we give them that ability to do that. What they end up doing is pushing the test button, the test load button will come on, and it works from there. You go to the right-hand side, you've got the same four buttons up here on the top, this being a ballast fixture mount type of ALCR. And then we've got what we call a remote test button. This remote test button is a little unique compared to our competitors. What's really nice about it is the fact you don't have to have high voltage going to it. It's a dry contact. It can set alongside the fixture. And really what's nice about it is you save on material and labor cost when installing. That's a key feature for us, and we're very proud of that. Here we'd like to show you an automatic load control relay with a switched utility detection. What this is an earlier device. We still sell a few of them, and we're very proud of them. But as we move on, we find that there are other avenues out there, other products that we're moving to make and passing along these. But simple, how they work is basically monitoring this wall switch over on the left-hand side. This is the application. And what it does is it monitors because these are up in the actual ballast channel. So what has to happen there is the fact that some way it has to know what's going on with that switch. So it's monitoring is what it's doing. When the emergency power or normal power drops, the emergency power kicks on. our product basically takes over control and brings that fixture to full brightness. Again, this is an ESRB01C and an ESRBE277C. Coil of 120, 208 through 277, pretty standard in the lighting world. This is a 10 amp contact rating, single pole, single throw, normally closed. I mentioned about the dimensions here, 4.6 by 1.2 by 1.7. Early on, this was the design we did. It played out very well for us, but what we decided to do was move on, and I'll show you a little bit here down the road here. So what you're going to have here is basically we're moving into kind of a newer feature. We've come out a few years back with this one. It's an automatic load control relay. It's our ESRN and ESRB. Two different, as I showed earlier, two different models, one for the plenary, one for the ballast, and of course the ESRTB, the test button. You notice these coil input voltages, 120 through 277, they're both universal voltage, so they fit right in. You'll notice the ESRN is a 20 amp magnetic ballast, single pole, single throw with a 16 amp electronic ballast. Over on the ESRB side, we've got a 10 amp magnetic ballast, single pole, single throw with a 10 amp electronic ballast. Both actually have the 0 through 10 volt dimming override. Both have the 2-second daily self-test included. The ESRN is nipple mounted. The ESRB is ballast or fixture mounted. I mentioned the LEDs on that drawing earlier. You can see that. I mentioned the test button and of course the fire alarm and remote test capabilities. If you notice over here, we mentioned the dimensions again, 1.32, 1.65 by 5.5. You notice we're getting a little bit thinner, a little small, longer, but we're trying to increase for that ballast channel. Here is an application for one without 0 through 10, and then we'll talk about 0 through 10 volt dimming override here. Basically, as we talked about, you've got your ATS, automatic transfer switch setting up here. You got your normal power here. We're actually feeding normal power. We've got a switch involved here. And our control circuitry basically is controlling, here's out here normal lights. We've got that on. We've got a normal emergency light up here in the upper right. So what's happening is when normal power drops off, emergency power kicks in, you notice this relay here in the center. It's a normally closed relay. What we are doing there is creating the power path for that power to get to that emergency fixture. Down here in the middle, you notice it says violet or terminal 1, violet or terminal 2. Basically, that would be where if you had 0 through 10 override would be attached. You notice it is open, there's nothing there. The section right below that is where it talks about white, red, and white, blue wires. That's your remote test wires. So our remote test is sitting there. You're able to do that. Many states, many counties within the states require that test button out there for the inspector to come through and test periodically. It could be 6 months, it could be yearly. So we have to provide that. That is what code says. So that's how we do it. Over on the right-hand side, we talk about the overriding of 0 through 10. So basically what's happening is over here, same circuit, our unit's actually controlling things the same way. But if you notice down below, what we have is a 0 to 10 volt dimming control panel down there. You notice we're controlling all those lights, those two lights out there. Normal lighting, we've got one up there, normal emergency lighting. What's actually happening at the top, when normal power drops off the bottom, that light goes out. What happens is that ATS switches over, we create the path for that power or emergency power to get to that emergency light. You see the violet, as I mentioned in the earlier diagram, you see the two violet colors. What's happening there is that is your 0 through 10 volt dimming going through there. So what we do, we break that circuit with that contact inside there, and that allows that normal emergency light to go to full brightness, as code says it has to. Here, what we've got is what we call an automatic load control relay. We brought in a little bit later. This particular one is basically its feature is very much like the ESRN, although the key behind this one is it has no 0 through 10 volt dimming override. What happens is you get different lighting applications where some have dimming going on, some that do not have dimming going on. So what we do is to try to provide, why spend the extra money for the override if you don't need it? So in this application, basically, you're doing the same thing. We're providing the path to get to the emergency light. We give you the test button. We give you the 2-second daily self-test. And I should explain that self-test. Basically, what happens is at the end of the day, take a classroom, for an example, the teacher shuts her lights off. That one emergency light will stay on for 2 seconds. The reason for that being is we're providing that information so every day they know that the emergency circuit's ready, available when needed. For 2 seconds, it's on, and then it will go off. In a real situation where you lost normal power, that emergency light's going to be on at all times until normal power resumes. Here again, you've got coil input range of 120 through 277. This again is 20 amp magnetic ballast and a 16 amp electronic ballast rating. Again, I reiterate, no 0 through 10 volt dimming override. This is nipple mount, and again, it's 2-second daily test, and it does have the remote test and the fire alarm system input with it. So really, it comes down to what your application really is. What do you really need? Moving forward, this is a brand new release. Actually, 2 weeks ago, this product has been released. It's our ERLBC and the ERLBC ND. We designed this for linear lighting. That's primarily where it goes, although it would go into a fluorescent ballast channel. It could go into a panel if needed. So it's not necessarily just for linear lighting, but that's what it's focused at. If you look down there in the lower right, basically the dimensions again, 1.0, 1.4 by 5.65. What we've done is stretch that out a little. The height of it is 1 inch and the width of it is 1.4. So what we've done is tried to fine tune our form factor to fit in for linear lighting is what we've done on this piece. It does handle the 120 through 277 just as our others. It's a 5 amp single pole, single throw magnetic ballast. You got to remember it's at the fixture level, so you don't really need a hefty relay there. It does have 5 amp electronic ballast ratings. We give you the 0 through 10 volt dimming override. What's unique about this one, we also give you the actual contact to actually override the dolly dimmable side of things. Something new to us, but primarily what happens is in theater settings and so forth, they're actually using a dolly protocol. So when they're doing that, they need some way to override and make sure fixtures come on to full brightness in case of an evacuation there. LED indicators, as our other products have, and the ERLBC has the 2-second self daily test. Localized test button, as we mentioned. It also has the remote test fire alarm system input. Now, what we did from that, we created a second model, and it's primarily when you think about it from the controller standpoint. Because if you're using a wall switch for the LBC model, what ends up happening there, you're seeing that 2-second delay. But when you're using it from a controlled environment, it changes things, and that 2-second delay needs to be scheduled through the controller and so forth. So what we've done with this ND model is created a no 2-second delay daily test, or a no delay in shutting it off when you do. And again, that was primarily focused to the fact of controllers and needing that to be able to do scheduling with their testing and reporting that into their inspectors. Here you can kind of see the override of 0 through 10 volt dimming. Again, over here on the right-hand side, You've got a white, violet, and a white. That's your 0 through 10 volt dimming override. Again, it's coming from a controller down below. And so when normal power drops, we break that, we open that contact. So we break it so the normal emergency light can have full brightness. Again, this code says it has to. In the dolly world, you're basically using the violet and the white brown to make a connection, because in the dolly world, you are passing along a current and power at that point. A little different, but it's the way they do work. Again, we've got a remote test in this. Our voltages on this, as we mentioned earlier, 120 through 277. Everything pretty much lines up pretty well. We're very excited about this new product, and look forward to moving forward with everybody. Here we give you just a table of our UL 924 emergency control products. Simple table. We pretty much share this with our literature that we pass out, we send out. If you were looking for an example, if you were looking for an electronic ballast rating of 10 amp, you go to the electronic ballast column, you pull out the 10 amp, you see that's an ESRB model. Now you look across there and you can say, oh, it's a ballast mount, and it definitely is not a nipple mount. It's dimming override. It has that. It has the local test button. It has a self-test. It has a remote test. It has a fire alarm input. So what we're really trying to do with this is give you an easy access to what our models do and what they support. From that, I'm going to turn it back over to Matt and let him have it from there.
All righty. Thank you, Dave. All right. If you guys have any questions regarding our products, needing price and availability, or order tracking, please reach out to us at sales@functionaldevices.com or give us a call at 800-888-5538. If you and your team would like a lunch and learn, please reach out to your account manager. They would be more than happy to do so. If you need product recommendations, installation, and application questions, or would like for us to create a custom product for you, please reach out to our support team at support@functionaldevices.com or give them a call at 800-888-5538 during the work week from 8 a.m. to 5 p.m. Eastern Standard Time. To access quick product information, spec sheets, CAD drawings, and frequently asked questions, check us out at our website at functionaldevices.com. And to keep up with the latest functional news, give us a follow on LinkedIn, YouTube, Twitter, Facebook, or Instagram. This brings me to the end of our presentation. Thank you again for tuning in with us while we went over our company history, product offering, UL 924 emergency shunt relays and their applications, and our customer support. Tune in on Wednesday, June 10th for our next RIB report topic, navigating functionaldevices.com. Thank you again for supporting Functional Devices. Have a great rest of your week.